Good morning. The reason why I chose my green heart, I live in Boston right now, and the Celtics got bitten pretty hard the last couple of days, so that's why my contribution to making their life a little easier. Showing some green, the Celtics, basketball for those people that don't know the Celtics. So I work for a company called Dynatrace. We're in the monitoring space, and I've been fortunate enough to work for them for the last 9.5 years. And we went through a major transformation as a software vendor, from delivering enterprise software, 2 major releases per year, to what we do now, where we deploy 2 feature releases every month with a lot of deployments happening during the day. And I want to share a little bit of that experience with you. And I don't get all of the credit because most of the stuff was done by our engineering team, by our operations team, by our DevOps team. So I want to show a little bit about the things we've learned. Hopefully you can get some of these lessons and take it back home with you. And great lessons, by the way, in the previous session from the Capital One guys. I thought that was quite fascinating. Now, when I speak at conferences and I typically introduce DevOps to somebody, I'll try to break it down to something that I can actually explain to somebody that is non-technical. All right? Has everybody ever tried to explain DevOps and the transformation we're in to somebody that is not technical, like your husband, your wife at home, your kids? Has anybody tried? Successful? No. All right. So my test environment for testing my story was actually my parents. All right? And this picture, they sent it to me yesterday. So I gave both of them an iPad 2 years ago because I'm traveling a lot, and so they should be able to stay in contact with me. So now they use Facebook Messenger all the time and harass me with pictures like this. My mom is 63, my dad is 71, and so when they explain what does Andy do to friends, he's fixing computers, he's making them faster. And so I always get called when somebody has a broken Windows machine or an iPad. But what I really wanted to explain to them is, what do I really do? What did we do as a company? And I came up with this example. I said, Mom and Dad, remember 15 years ago or 20 years ago when we went on a family trip and we started taking pictures? We had a camera like this in our pocket and we started taking pictures, right? And we took 10 pictures, 15 pictures, and the film roll wasn't full, we took the camera home with us, including the half-full film roll, and went on the next trip weeks or months later until we made it completely full. And then we have what I call 24 features in a box. My analogy to waterfall development, right? So then we give it to some company that actually knows what to do with it. Developing the pictures, I'm sure they have great quality control, and the guy who sits there says, this is a perfect picture from my perspective, so I ship it back to the customer. And then typically there was this moment, and I remember we got the envelope, and then we had to think about what pictures did we actually take. I don't even remember. Which features did we put into this 6 months release? And then sometimes reality kicked in. That somebody photobombed our family reunion picture, right? Which obviously leads to frustration because you don't want to put this into the photo album. Nor at that time, there was no Photoshop where we can make this better. But this is kind of my analogy to waterfall development. Big bang release, and then we ship it to customers, and they say, not what I expected, it's no longer relevant, and I went with your competition in the meantime because I needed something at the time when I told you about it. Make sense? Right? So how do we take pictures now? And how did I explain my mom what we now try to do differently? This is the moment where I need to bring in my girlfriend, Gabi. She's from Colombia. I am from Austria. We both live in Boston right now. We actually met on the dance floor, and we had a talk in the beginning how they introduced me. My second passion behind performance engineering is salsa dancing, and that's where I found my girlfriend. So we live in Boston, but eventually I want to show her and bring her to Austria. And last year we went to Austria and we hiked in one of the Alpine lakes. And what she does, when she takes a picture, she takes one picture at a time and immediately sees how the picture is going to look like. Even better, thanks to Apple in her case, she has automation in her delivery pipeline where she can apply filters to the picture and make it better. Until she's confident enough and comfortable enough saying, this is the right quality that I now want to push into production. Her production is Instagram and Facebook. Her customers around the world are friends and family, but particularly her dad, who still lives in Colombia, and she wants to make him happy, right? And she wants likes. If she gets dislikes, especially the last couple of months, especially in the US, we live in the US, if you post something that is not politically correct, sometimes you piss people off. So you may want to take it off. But in this case, she gets likes, and maybe she gets a comment from her dad, and she says, so you're in Austria, where's Andy? Are you still dating him? What's going on? And because she's still in that moment, and she's a fully automated pipeline, she can take yet another picture with me in there making her customers happy, in this case, her dad. All right? And this is actually what I try to tell my parents, what I'm doing, and what we all try to achieve in the software industry is automating and changing our delivery model of software instead of big bang releases, smaller incremental releases. But the bigger change for me, and I have to phrase it in the word that our CTO used to call it, instead of having developers, testers, and operations, we did a 90-degree shift. Because now we have application teams that are end-to-end responsible for what they do. My girlfriend Gabi, she has to decide which pictures to take, how to optimize them using her delivery pipeline until it's good enough for her, then deploy it into production, and then figuring out what to do with the feedback. And this is what we achieved within Dynatrace in the last couple of years, and I think this is actually what a lot of us want to achieve as well, right? When we talk about DevOps, the cultural change. So I've been with Dynatrace since 2008, actually, and I now want to go back to our story. Back in 2011, there was a pivotal moment that forced us to change. Back in 2011, I mentioned earlier, we did 2 major releases per year, especially for our on-premise products, where we monitor applications. Back in the days, we were 250 people, so it used to be a startup in Austria, 2006. I joined 2008. In 2011, we were 250 employees. We are ranked at the #1 player in the APM market, and we felt pretty comfortable. But then what we saw, damn it, we felt so comfortable in our space, and we totally ignored our competition and what they are doing. We totally ignored the cloud space. People like New Relic, App Dynamics, and others came up, and we were almost too late in realizing that we need to change, and we had to figure out what to do differently. So we wanted to adapt to that because we wanted to stay in the marketplace for longer. At the same time, we had another thing that actually caused a lot of, well, it's a curse and a blessing, as I always say. We got acquired by a big corporation called CompuWare. They were big in mainframe. It was a blessing on the one side because all of a sudden we were global, but it was also a pain and a curse because instead of being a small startup where we were really flexible, we were all of a sudden part of a big organization with processes that we never thought exist. It could slow us down. The biggest benefit or the biggest kudos go to this guy, our CTO and founder, Bernd Greifener. He said, we need to change. We need to build new software that is fit for the next generation of software that we want to monitor, and we also need to deliver software in a different way, the same way as our future customers deliver software, continuously. The biggest challenge was not technology, it was really organizational, and we had, and this was discussed yesterday many, many times, we had a top-level buy-in. He said, I'm going to allow the development team to figure out how to make this work, and I block everything that happens in corporate, and I allow it to fail. So we were fortunate enough to have a top-level buy-in. What we achieved, so instead of going from 2 major releases per year, in 2017, we are doing 26 feature releases, so every sprint, we have 2-week sprints, every sprint gets delivered into production, and that's true for our on-premise soft offering as well as our SaaS offering, and for our SaaS offering, we do 500 deployments per day, and I'm talking about deployment changes, not features, obviously. What we also have, we have a delivery pipeline that allows us to push a code change from development into production within an hour, if it's necessary. If customers say, hey, you just broke my environment, that's obviously not good, so we want to fix it as fast as possible, not have to wait for another 2 weeks. So I want to give you a little rundown of what actually happened, because I assume, or let's do it this way, who is not working in a startup here? Who is dealing with legacy software or enterprise software? Right? And I assume most of you want to change, right, and have different approaches. So our approach was the following. Back in 2011, we said, okay, we have our enterprise product, what do we do? Well, let's try to run it as SaaS, because this was one of the things our customers told us, you don't offer SaaS. So we gave it to our operations team and said, we need to run this as SaaS, and we need to be able to make a lot of frequent updates. And it was very frustrating for us, because we had to deal with an operations team that was still in the mainframe, kind of hooked in the mainframe days. And it was nothing bad about the mainframe days, but they had change requests meetings, so when we wanted to deploy a change, we had to file a ticket that was discussed every Thursday in the morning, and the next week it was potentially deployed. This was obviously not the way we wanted to do software delivery. So, too slow. Then we said, well, let's do a lift and shift. We take our enterprise software, put it to the cloud, and try to figure this out without the NOC team. But then the developers said, well, this is not what I want to do, right? If we're taking ownership, we had the discussion, like, how do we get developers encouraged to do operations? They basically said, no. So what we did is we founded and started our DevOps team. It started with 7 people led by Anita. She's our DevOps lead. And she tried to figure out how to build an orchestration layer and a pipeline back in 2011, 2012 maybe, so we can leverage the cloud and deploy our enterprise software in the cloud and run it as a SaaS business. And that actually worked pretty well for the beginning, but we had a lot of lessons learned. Once we started to deploy more frequently and actually had to run our own enterprise product in operations as a development organization, we all of a sudden understood why it is so painful for our customers to run. The first challenge was going from 6 months to 1 month. And as you can see from the back, we had a 1 gigabyte monolithic application that is already painful to install once or twice a year, but doing it on ourselves 12 times a year was even more painful, right? It was a very error-prone update process, as we figured out, very hard to automate. So what we actually then did, we took the monolith, we didn't break it into microservices, but we just componentized the whole thing so that we can automatically easier deploy these components, update them individually, and this actually allowed us to go faster. And you can see all the other stuff we did. We put in automatic rollback and updates, A/B testing features, so we can actually deploy something to a certain set of customers, test it out, and then get the feedback. But getting faster showed us more bottlenecks that we had. Another thing, I started with Dynatrace in 2008, and back then we already did agile development. We had 2-week sprints, but it was more like 2-week sprints for 5 months and then a month of hardening. Right? It's the classical agile fall. And what we said, if we need to get comfortable enough so that we can actually deploy the sprint build into production. And the first thing we did is we actually forced our engineers to show their new features in our internal production environment. So we are delivering monitoring software. We can, as a software company, need monitoring software to monitor our SaaS system. So we used Dynatrace on Dynatrace to monitor our website, our Jira, Confluence, Salesforce, and all these critical components with every sprint build. Which means, as a developer, I could only show that I actually implemented a feature in our internal production environment. So I had to make a conscious decision. If I commit this code to the sprint build, then it goes up in our internal environment, which potentially brings down our website, our Jira, our community portal that runs on Confluence, in case I make a mistake. And that happened quite a bit in the beginning. Right? We broke our Dynatrace.com went down because of developers checking in bad code. But the good news is Bernd, our CTO, he didn't punish us, but he encouraged us to learn from these mistakes. Right? What the developers also learn, once you see the impact of software change that you have to not only your customers, but actually to your colleagues and to yourself, you have a total different sense of quality. That also forced us to invest more in testing and therefore increase the quality a lot. What we basically then said, some people say, you eat your own dog food. Well, we basically said, well, in the beginning it was dog food. It turned out to be champagne in the end. So we drink a lot of our own champagne. Another thing we learned, feedback loops are very important. And I have my colleagues from sales sitting here, and I have to point out, especially to Mike in the front, we used to be a very sales-driven organization. So sales said, in order to make this deal, we need this and this feature, otherwise it's a no-go. Right? I'm sure you've heard this before. So what we started doing is actually figuring out which features are actually used by our customers and how many of these features that these guys told us to implement are really used in the end. So we actually knew which features can we actually kick out because nobody needs it anymore, which salespeople do no longer listen to because they always tell us things that in the end nobody needs anyway, and actually trust more what our community tells us because we also opened up our community where people can directly give us feedback, people can vote, and we're no longer driven by just individual people that shout very loud. Right? So it was very, very important for us. Another thing is the more updates we did and the more we got developers engaged with dealing with operations problems, they said, this is so painful. I always have to go through the log files, and basically I always find the same things. So what we actually came up with, the development team came up with a tool that we called Archie. Archie is our automatic log archive analyzer. So every time when a customer opens up a support ticket and they are uploading a zip file with logs, we automatically parse through the log files, and then we have a rules engine that the developers can actually extend and say, look for these particular log message. If it's this and this, then here's the answer. And that helped a lot. So now we actually force our customers, every time when they open up a support ticket, they have to attach this log file or these log files, and then RG gives automatic answers like a bot, right? It's a support bot. Helped a lot. Other things we started to learn, moving to the cloud is great. It allowed us to scale, and it's great for many other things. We use the cloud heavily now for testing, for running automated tests. But it also ain't cheap if you make mistakes. What you see here is a graph showing, I think on the right side, it's memory, and on the left side, CPU. On July 3rd, I believe is the date here, we made an update, not with new features, but one of our third-party software vendors that we use for distributed logging. They told us you're on an old version of our system, please update, because there's some security concerns that it addresses, but also performance concerns. So we updated the library, blindly trusting them. That library had a memory leak, memory went up, garbage collection went up, CPU went up. Thankfully, back then, we had a mode where we could automatically add more Amazon resources to basically mitigate the problem so that end users were not impacted, but in the end, our financial system was impacted because without having any new features, we had to pay 4 times as much for Amazon. So we learned a lot. Also now we are looking at these metrics early on in testing. So when we now run tests, we do not only look at functional results, but also at memory consumption, resource consumption, and find these problems early on. All right, so this was kind of our first steps from going from 6 months waterfall, 6 months deployments to a month, and then every other week. Then what we said, well, in order to really leapfrog, we need to incubate. So back we were CompuWare, and then we did 2 things. CompuWare actually got acquired by a software investor, and they spun us out as Dynatrace again, so we could innovate, keep innovating on our enterprise product. But what we also did, we actually said, and again, this comes back to our CTO and founder, he said, I want to not buy another company for making leapfrogs. I'm actually incubating a startup. So we incubated a startup within our organization, and again, shielded them from everything else we had, shielded them from all the processes, and told them, you now have time to figure out what is the next generation of monitoring tool need to look like, and how do we deliver it in a very modern way. Build something for the cloud, because we want to monitor the cloud in the future. This is when we also redefined the role of our DevOps team. So remember Anita, she's the DevOps lead. Her team, at this point, grew a little bit because they had to do one thing. They became product managers, and their product, they actually had 2 products. Their product is the pipeline and the orchestration engine. So they had to figure out the full pipeline, all the sets of tools that we use to push code from dev into testing, into staging, and into production. And also developed and improved our deployment, our orchestration engine to scale up and down on demand. So this is the product that they owned. Their users and customers were the individual application teams. So if I point at the guy in the first row, if you would run a development team within Dynatrace, you basically go to Anita's team and say, how do I deliver software? Then she shows you how all this works, and then how to write your code, where to check it in, how to run the test, how you can write your own tests, and how the whole process works when you put the button until it gets all the way through. And if you say, well, this is not what I need this technology, then you can negotiate with them so that they can extend their pipeline with the tooling, with the technology that you need. Okay? So as you can see, some pictures here, how we visualize the pipeline, how we integrate into Jira. We also figured out logging is very important, log analytics, and giving developers especially access to production logs and production monitoring. And that also influenced a lot in how we actually implemented Dynatrace. We put a lot of additional features into our monitoring solution to cover a lot of these things. So the biggest lesson learned is monitoring for us as a monitoring company obviously has to be part of the pipeline. Why? Well, because the pipeline, right? Why do we have a pipeline? Because we want to innovate faster, and we have quality gates before we push code out. We also want to get feedback through monitoring, right, from production maybe, because we want to know are our users happy, because that's the ultimate goal. Like with my girlfriend, she wants likes and not dislikes. And also, we want to make sure we're not exploding the costs. Just because we have an automated, distributed, upscaling environment, we should not allow every code change going through and killing our budget we have for EC2, for instance. What we also noticed, there's many more chances of using monitoring along the way. The term shift left has come up a lot this conference. We enable our developers to spin up their own environment and run some, we call them unit performance tests. So running unit tests in a distributed way and actually using monitoring tools to figure out how much memory is consumed, Do we have any synchronization issues if this code is executed by more than one thread? Also, in continuous performance testing, we not just run load and understand response time, but then also look at the internal behavior. Again, coming back to memory and resource consumption, and so on and so forth. On the business side, we do a lot of A/B testing and blue-green deployments. So monitoring gives our product managers the chance to say, well, you just deployed a new feature to 10% of our customer base. Here is how they react to it. And then they can make decisions and keep either promoting or rolling back features. But they have better decisions now because, or they can make better decisions because they have better data. All right. One thing we had to do is, and we invested a lot in this at this time, where are the guys from Capital One again? Are they still in the room? Yeah. You have this Hygeia project, which I really love, visualizing the pipeline. It wasn't available back then, so we built our own pipeline visualization, how individual development teams are pushing their code changes through the different environments. A key thing was to get the build time down to 10 minutes, because if it takes longer than 10 minutes, it just takes too long. And we also had to figure out a way how to actually visualize pipeline quality. And what you see here is, and I need to enable this now on my machine here. One of the things that we came up with, we wanted to show quick feedback. And I was hoping, actually, by the way, if somebody is in the audience in the first rows, you will find a Wi-Fi hotspot that is called UFO. So our chief software architect came up with this thing. I'll have to keep it in my hand. We call it the pipeline state UFO. And we actually place it next to the coffee machine. And this is not a joke, right? This is real. The good news is this is an open source project now. So our chief software architect, he was so frustrated that the developers, they do some great coding, but sometimes they just code the whole day, and 5 minutes before they go home, check in the code, go home, and then the build breaks half an hour later. And we have a global distributed team. So they impact other people. What he said, we need to get build times down to 10 minutes to give feedback. And we hook this up to our Jenkins pipeline. There's 2 rings. The top ring visualizes how far the build goes in Jenkins until it breaks. So if it's fully red, it cannot even compile. If it's a little bit green, it means unit tests went good, integration tests and so on. So the idea is the top ring should always be green because it visualizes the state of the pipeline. The bottom ring represents the state of their feature in production, hooking it up with production monitoring. So do we have any unusual high number of error rates, any performance issues? Right? And if we place this next to the coffee machine, left to it is the door to the office. So before you go home and your UFO is not green, you know your team is on fire. And it might be you that caused it or somebody else, but before you go home, you at least want to check it out. So it's an open source project. If you have a 3D printer, you can print it yourself. And it's on GitHub. Dynatrace, the code that runs it, there's like a processor and some LEDs. It's very easy to assemble. And yeah. We encourage you also, and this is part of our raffle we have later on, to give us some ideas. We raffle off an Echo and some books. So if you send me some ideas later on, then we pick the best ideas. All right, UFO was a major transformation change. So I want to now show you how it really looks like. Shift left is a big thing. So we run, as you can see, 31,000 unit and integration tests per hour and 60 hours worth of UI tests per build, using different type of testing tools. And this is great because these tools tell us functionally good or not. But what we said, we missed a great opportunity. We put monitoring into these tests, unit tests, integration tests, functional tests, and basically, oops, not this, basically baseline every single metric. Memory usage, number of database statements, number of exceptions, number of web service calls, how big is that page that I'm testing? So we're taking all these metrics and baseline them for every single test and for every single build. And we baseline them, and if a developer makes a code change and functionally nothing breaks, but one of these metrics goes up through the roof, then we basically break the pipeline. Whether it's Jenkins or Bamboo, we use Jenkins internally, but so we built this into the Dynatrace product and have integrations with the major CI vendors. And obviously the UFO goes red, right? Another thing we do continuous performance. So we have an environment that is constantly under load. That means there's constantly a load test running, and every day we deploy a daily build in there, and it serves 2 purposes. We can validate that our deployment process works when we roll out a new version, and we can also validate how the performance of particular components are. And what we do, we came up with the idea of a so-called performance signature. So a performance signature depends on what component you're looking at. It could be throughput, it could be response time, memory, or resource utilization. But we basically look at this signature for every build that we push through that continuous performance environment. And then we can, again, make decisions. Is it a good build or a bad build? And do we push it forward, yes or no? And also fully automated. Last lesson that we learned, we want to deploy faster, we want to fail fast, and we want to recover fast. We actually came up with, we deploy more frequently. That means our customers had more chance to use new features, or our marketing teams had new chances to promote new features. What you see here is a chart or a dashboard that our marketing team now looks at on the top, how many users actually are on our website. And we categorize them in 3 simple categories: green, happy; orange, tolerating; and red, frustrating. We factor in performance and errors. And on the bottom, it's conversion rate. And the story to this is, I'm not sure if you can read it. The timeline is, I think, April 25 until May 1st. On May 1st, we were promoting and pushing new features, and our marketing team said, we are going to promote the hell out of this new feature because we want to get people on our website and sign up for our free trial offering. So the marketing team started the marketing campaign, and now they look at the monitoring data, the end user monitoring data, and say, looks good, the users are up, conversion rate is up from before, so we hit the right people and they all sign up. Day 2 comes along, marketing campaign goes on, users keep growing, oops, number of not so happy users goes up, oops, conversion rate drops. What we figured out is, and the application team actually already jumped on it, they saw that their feature, the team that was responsible for the sign-up page for the free trial offering, it's a sign-up form that makes multiple calls to a marketing backend and another backend. They said, well, you hit a certain inflection point where we actually get slower and slower, and so that's the root cause. And then the marketing team said, well, we still have 5 days to go in this campaign. Can we fix something? And the development team said, I pick you now, the next guy. He said, sure, and I have a deployment pipeline that can deploy in an hour. So I deploy a fix in an hour, I hack it in, run it, deploy it, all good, and boom, crash. So the crash, what you see here is the number of happy users went down, frustrated users spiked, and conversion rate dropped. Basically meaning these UFOs now, we have a UFO also for the marketing team. It went red. The marketing team uses it to visualize conversion rate of their campaigns, and your development team monitoring how is your feature doing in production also went to red. So you immediately knew something is wrong. What was wrong is you developed on your Mac, using your Google, your Chrome browser, fixed some JavaScript, everything was good, pushed it out and forgot that there's a certain demography of the world that uses Internet Explorer on Windows. And unfortunately, you had a JavaScript error. So that means the sign-up form was not available. Fortunately, you got a notification, they got a notification, but before they could punish you, you said, well, I already have a hotfix for it, so everything is back to normal. All right? So these are some of the lessons learned in speeding up deployments, but then also reacting and failing faster. Now, another thing that we learned, and I put this message in because last night or yesterday afternoon at the open spaces we talked, I was part of the alerts discussion, and people were saying, we're getting drowned with alerts, it's not actionable. It's the same problem that we ran into. The marketing team got alerts, and the development team got alerts, and the infrastructure team, they all get 10,000 alerts. So we actually built in our product something that doesn't drown us in alerts. So the first thing we do is we tell our teams who is actually currently impacted. And is it just 2 people, or is it like 1,100 people? That totally changes the game of, is this something I need to be woken up or not? And then not everybody maybe understands all the dependencies, right? Who is really impacted and what's the root cause? So we also built something in the product where we can say, this is really the impact and the root cause. So Dynatrace.com currently has a JavaScript error rate increase. We have 10,400 user actions affected. Oh, it's really the Windows users. Remember that browser desktop, yeah? Then what we also said, problems don't just typically happen and start in one particular component, but it may have different issues and that trickle down through the system. And so what we also came up with is with an events correlation that actually shows me a problem and also all the events that basically came up in all the depending components, like a CPU saturation, strange log file, something crashing. and we present this to our operations team or the team that is on call so that they know there is a problem, here's how the problem evolved, and here's the root cause, right? Because we had to become faster in dealing with these issues and not being drowned in alerts. So the typical tool chain now of an engineer at Dynatrace, so if you, I didn't want to scare you away, so hopefully maybe we also hire, by the way. Our engineering teams, just as the same as my girlfriend, right? They're responsible end-to-end for what they do. She's responsible for taking pictures and putting them out, and developers are responsible for putting great features out. They're using, obviously, monitoring in every single pipeline phase. We also now introduced ChatOps, so I also was part of the ChatOps discussion last night, which I thought was very interesting. Our engineers can talk with the monitoring tool through chat and don't have to always go to the dashboards and look at the stuff. And we also introduced Alexa, so people in the marketing team, especially in management, they can actually talk to the system. Yeah, last step. We bring it all back together, so we incubated, ruxed it, and brought it back to Dynatrace. And this was actually very interesting because we brought back engineering teams. We taught the enterprise engineers what the cloud natives were doing and all the way around. And so it was just a big benefit. And here are just some of the numbers that I think I mentioned most of them already. How many tests we do, how many releases. The best number that I have not mentioned yet is 93%. In the old days, 100% of our problems were reported by our customers through Jira tickets, support tickets. Now, 93% of problems are detected by engineers proactively before they impact the customer, because we changed that model of you become responsible for it. Good. I think this means I'm almost done, right? Yeah. We talked about a raffle, so we have an Echo to give away and also a couple of DevOps handbooks. If you have a creative idea on how to use such a UFO that has 2 times 15 LEDs, and you can visualize obviously whatever you want, please tweet the ideas to @Grabner Andy, that's my Twitter handle, or track me down in the next couple of hours, and then we raffle off the Echo and the handbooks for the best ideas. And I think that's it for me.
So we can get some time for Q&A.
Perfect. Okay.
All right, we have a few minutes for questions.
Okay. Who has a question? No questions?
Are your devs on call?
So not all of our devs are on call. So we still have this DevOps team that Anita runs, and basically they are the first line of being on call, and then they basically handle it. It's a team of 4 people right now, and they do it similar. They rotate, but they are on call and they know who to get in case they can't fix something. We put a lot of efforts into automating problematic situations. So the system itself, I don't want to call it auto-healing, but we automated a lot of the traditional runbooks. So one of the cool things we learned from the Computer days, we talked with the operations team and learned what they've been doing over many, many years because we had no operations experience. We looked at the runbooks and basically saw they look like scripts, just written in a different way. And so we automated a lot of that. But on call, individual engineers, not yet. It's our DevOps team who maintains the pipeline. They're on call right now.
No answer. They're too busy doing deep work.
Yeah, exactly, yeah. I like the deep work.
I have a question over here. You mentioned a application that you built for Jira to scan your logs.
Yeah.
Is it sort of like Hercules for Atlassian product?
No,
is it a homegrown application?
It's a homegrown because so whenever our customers open up a support ticket, then we use Jira for that. And whenever they upload a certain file format, it's our support archive, it's a special zip file, then we actually parse that. It's a homegrown tool. It's a homegrown tool, it's a rules engine, and the developers itself, they build the rules in. Because if you're a developer and you push code out of your feature, you know which logs to expect potentially, and you can actually define rules and say, if you ever find this log message in combination with this and this, then please automatically respond to that Jira ticket that there's already a fix for it, for instance, or do this and this. We just automate all of this processing, but it's homegrown.
Next question.
We go in here.
That picture that you had on your slide that correlated a bunch of different events into a single thing.
Yeah.
Is it your product?
That's
or
our
is it-
product, yeah. That's what we traditionally just, really did, application monitoring, APM. But when we actually moved to the cloud and we built our distributed, highly scalable architecture, we found also out we are drowned in events of our own tool. And that's why we actually came up with, we sell it as AI, artificial intelligence, because we have a dependency tree and we baseline every single metric and we find anomalies. But we basically try to figure out a way, how can we correlate all of these events into one tangible, actionable thing? Impact, root cause, and how the problem evolved. Instead of having 50 events or 1,000 emails from 1,000 different tools, it's just one thing.
That's really cool. Thank you.
Welcome.
We'll take one more question.
Hi, this is about how we do performance testing. You mentioned that you dedicate an environment per dev, almost like.
Yeah.
So how do you manage stale environments, and do you put a limit to it? Like there's like a ticketing system. Like how do you measure that?
So the continuous performance environment that I showed, it's constantly under load. That's managed by our performance architects. So we have a particular team of senior software architects, and 2 of them are dedicated to performance. So they own that environment. It's basically a production replica, and they constantly run load against it. And they are to test the deployments, that a deployment doesn't have an impact on running operations, and they do these performance signatures, right? They figure out for the individual components that get updated, how does their performance behavior change from a throughput, response time, resource consumption perspective. Yeah? That's constantly under load. Developers, they can, on an ad hoc basis, say, I need an environment, just spun it up, using the same orchestration engine that we also use for all the other environments. So that's why the DevOps team who built the pipeline was so essential, because they were basically saying, this is the pipeline, and in whichever stage you deploy, you use the same tools. And you always get the same results.
Excellent. Thank you, Andreas.
All right, thanks, Andreas.